Okay, here it is.
Hello, Vern. Hey, I'll giving a tour. So you can see that exactly parallel to the building we were seeing upstairs is the accelerator tunnel itself. The main pieces of it, which go over and over and over again, are this big gray light pipe here. And inside this pipe is actually a big alignment laser. There's an alignment laser and a series of targets that you can put in over and over again. And that is what defines sort of the single straight line that you're trying to build this thing to. If you think about it, building something this big, you don't want it to be crooked, you want it to follow a straight line. So the way you do that is to take a laser pulse, which will go in a straight direction, and then put everything right on top of that laser pulse. So the laser pulse is inside this big metal can right here.
What does the laser pulse do?
The only thing it's doing is defining that straight line so that we know where to put the accelerator. So the very first thing, like if we have a big earthquake, is that can help you realign things. If they shift by the level of a millimeter, it allows you to at least get the entire thing straight to within about 1 millimeter of distance. And then mounted on top of this are a series of, you can see it over here better. A series of strong mats. So this is just a box-shaped aluminum beam that provides a rigid support. And then there's the accelerator itself. Now the accelerator itself is what's called a disc-loaded waveguide. It's basically a bunch of copper discs that are all sandwiched together and they repeat over and over and over and over again. So what this thing looks like inside is it's a big piece of copper that has a hole in it. And that hole gets bigger, smaller, and it repeats over and over and over again. Now what happens is, when those high-power microwaves that we made upstairs come down into the waveguide tube, they come into that thing and they travel down this copper structure. When they do that, right in the middle of the copper structure where there's no material, copper, they make a big electric field. So when those particles come in, they see that field, it's like a traveling wave, and they surf on that wave, and they go riding down and gain energy as they sail on down. Now this ugly-looking gray metal here is a special kind of metal called mu metal. Because what it does is, if you know the way compasses work and the way sailors used to navigate is using that the Earth has a magnetic field, the North Pole and the South Pole. Well, the magnetic field from the Earth is fairly small for a short distance. So when you add that field up over 3 kilometers, it can be enough that it can actually steer a particle beam. So that's what this gray metal does. It shields out the